All right, today we're going to go ahead and move on. We've been practicing with solving one-step equations, so now we're going to be practicing solving two-step equations. So we're still going to be practicing the see and solve like we've been looking at, but before we do that, I'm going to show you with the picture of why this works out. So when we look at this, the x, our variable, is going to be this little, I use a black marker to make it a little bit easier to see. This x is going to be our variable, and then the integers are going to be the little boxes, the squares. So remember with subtraction, we could rewrite this to add a line, change the next sign. So remember, subtracting a positive is the same thing as adding two negatives. So that's why in our picture we don't have positive 2, they're actually negative 2. Okay? So what we want to do, like we were doing with the see and solve, how we would solve this is add 2 to each side to get rid of negative 2. So what we're going to look at, if we were to add 2 to one side, what you do to one side, you do to the other, we're going to add 2 positives to our drawing. And what we do to one side, we do to the other. And now we're going to create 0 pairs. So those are my positives. So the shaded in represent negatives and the unshaded are positives. So I'll draw this right here to help you out. Okay, so then after we do that, if we were to create 0 pairs, a positive and a negative cancel out, that gets me x over here. These are all positives, so they cannot cancel out, so we know that x is going to be equal to 7. And here again, we can double check. If you take 7 and plug that in, 7 minus 2 equals to 5. So this helps us to see it with the one step with the picture to then help us to get to the two step. And then we're going to eventually practice without having to draw those pictures. So here again, if this is a y, my variables are going to be my rectangles, so I have 3 y's that are sharing 9 positives. Well, I want to see how much one y is worth. So if you look, for every one y, I see 3 positives. I see another y and 3 positives. Another y and 3 positives. So that means that y is equal to 3. That's proving it with the picture. However, we could do like what we did yesterday and solve it with the math as well. And we could say, okay, well, if I had 3y is equal to 9, I see multiply by 3. So if I see multiply, I'm going to solve it with divide. So divide by 3. That cancels out, and sure enough, we prove it with the math. So this might help you with the pictures with those one-step equations as well. So let's use that to go ahead and get to these two-step equations. So remember, what we do to one side, we must do to the other to keep this little seesaw, this little thing balanced for our equation. So the first thing we did is we actually added or subtracted the constant. So if you had a number that was just the number by itself, it wasn't in front of the variable or right underneath it, that's called our coefficient, then that's what we're going to get rid of first. Then we're going to divide by the coefficient because these y's were sharing these positives and we want just one group of those y's. So this will make a little bit more sense when we do this. All right, so right here we have our 3 x's, which are our rectangles, and 4 positives, which are our squares. Okay? And then on the right-hand side we have a negative 2. So we want to say with this picture how much one x is worth. So the first thing we need to do is get rid of what else is with x, those 4 positives. That's why we're adding or subtracting. Remember, it's the inverse. So the opposite of 4 positives is 4 negatives. So 1, 2, 3, 4. And I shade them in because they're negatives. And what I do to one side, I do to the other. 1, 2, 3, 4. Shade those in. Okay? And I'll come back to this part in just a minute. Now we create zero pairs, a positive and a negative and a positive, however you want to say it, cancel out. And that's what we want because we're one step closer to getting those x's by themselves. So there was 3 x's and 4 positives, but now because we created zero pairs, we have 3 x's not sharing 2 negatives because what we did to one side we had to do the other. Now that we have 4 negatives over here, you can see that there's 1, 2, 3, 4, 5, 6 negatives. So now I want 1x by itself. So for every 1x, I see 2 negatives. So in this problem, x equals -2. So basically, we subtracted the constant because the opposite of +4 is -4. And if you put 4 negatives on each side, -2 combined with -4 is -6. And then -6 divided by 3 is -2. So we'll practice that without the pictures later on. We just want you to see this visually with the picture for now. Okay? Again, we can always double check our work. If this was my original problem, then we plug in a -2 or substitute where we see x. 3 groups of -2. Remember, we order of operations. We multiply first. 3 times -2 is -6. Bring everything else down. A negative combined with a positive. The signs are opposite, so we subtract. 6 minus 4 is 2. There are more negative ninjas than those positive pirates. And sure enough, -2 is equal to -2. So that means that this is balanced. So the only number that we could multiply by 3 and then add 4 to get to -2 is that value of -2. Okay, so we're going to practice 3 more, and then you can try drawing these on your own to see what the value of x is worth. But again, highly encourage you, and you should be, checking your answer each time so that way you understand if you're correct. All right, so let's do a couple more. So we have 2 x's on the left-hand side, -3. Well, remember, add a line, change the next sign. So this is 2x plus -3. Okay, subtraction is really adding the opposite. And we have 1 positive. So we're going to get rid of these -3's with 3 positives. 1, 2, 3. But what I do to one side, I have to do to the other to make it balance. 1, 2, 3. Now I create zero pairs where I can. Positive and negative create a zero pair. It's like you have $1, but then you lose $1. Now you have nothing. And now I have 2 x's sharing 4 positives. So if this were a multiple choice question, x equals 4 would be a trick. But x doesn't equal 4, 2 x's equals 4. So for every 1x, I see 2 positives. So x equals +2. And here again, you can substitute that information right here. 2 times 2 is 4, and 4 minus 3, as it was originally written, is 1, or 4 combined with 3 negatives is also 1. So just get in the habit of checking through these. Okay, 2-step equations are very difficult to do in your head, and that's why we're having you not do it in your head, because eventually we're going to be working with fractions and decimals. So if we're getting you to practice this now, it's going to help you to understand those harder problems later. Well, on the left, over here, we don't have our x on the left, we have it on the right, but still the same concept. We have 4 positives right here, and we have 3 x's. Well, subtracting 2, remember, subtraction is adding the opposite, so that's where we see 2 negatives. So our ultimate goal is to get these x's by itself. So we're going to get rid of the constant first. Well, if I see a -2, the only way to get rid of a -2 or subtracting 2 is to solve it with the opposite, which is adding 2. So we're going to add 2 positives to both sides. Remember, what you do to one side, you do to the other. Then we create zero pairs, and sometimes you'll have zero pairs on both sides, and sometimes you only have it on one, and that's okay. These are all positive, so we're not crossing anything out. These was 1 positive and negative, 1 positive and negative, so we canceled out. So on my left-hand side now, I see 6 positives being shared by 3 x's. But if I want to know the value of 1x, well, think about it. 3 in front of x means multiply, so the opposite of multiply is divide. And if you can see it just like that, for every 1x, how many positives do you see? You see 2. So x equals 2. Again, you can substitute that in right here. 3 times 2 is 6. 6 combined with 2 negatives is 4. Or 6 minus 2, the way it was originally written, is also 4. So that's the only number x could be to make this equation true. All right, let's look at one more together, and then you can try these two out on your own. Draw those out on a separate sheet of paper and see what you get for the value of x, and double check with your teacher. All right, we've got 3 positives right here. They're not shaded in, so they're positive, and 2 x's. Then we have 7 positives. So we want these x's by themselves. That's called isolating the variable. Isolate means get by itself. So first, we're going to add or subtract the constant. So the constant right here is just a positive 3. So the opposite of positive 3 is 3 negatives. What I do to one side, I'm going to do to the other. Now we're going to create our 0 pairs to get those x's closer almost by themselves. We have them by themselves almost. Not by themselves until we create those 0 pairs. And I also have 0 pairs on the right now, positive and negative, positive and negative, positive and negative. So after those 0 pairs, that's like they're gone, we have 2 x's are sharing 4 positives. And we want 1x by itself. So for every 1x, I see a positive 2. So it just so happened that this answer was 2 all the way around, but we proved it with the math. And again, you can plug this in. 2 times 2 is 4. 3 plus 4 is 7, so you know that you're right. All right, try these other 2 on a separate sheet of paper and check with your teacher, and then practice the problems that are given to you as well.